Welcome to this presentation. I would like to introduce you to some of the recent evolution in safety and cybersecurity. The Vector projects and our portfolio cover a lot of these two topics, and I want also to introduce you to some of the evolution in terms of standardization, but also how to efficiently implement functional safety and cybersecurity at the same time. The Vector Consulting branch, part of the group, similar to Vector Software, covers several industries. Of course, the majority is in automotive, but since we try to also benchmark best practices from other industries such as aerospace or medical or industrial automation, we also work in these other industries with clients worldwide, and so we can also draw experiences from other situations, specifically cybersecurity. We see in the world of IoT currently a lot of evolution which fits to this evolution now in automotive, in the convergence of electronics and the computer-driven systems. I want to emphasize, first of all, where are we going with our annual customer survey. And what we can see here is that we have on one side the horizontal axis, the short-term challenges, the vertical axis, the more mid-term challenges. And we see some interesting pattern here, namely that for the short term, cost and efficiency, that is the speed, are very important. For the midterm challenges, it's security and safety, our topic here. And seems that this thing is not good working. Maybe. Okay, it seems to work again. So what we can draw here is what we call this automotive magic triangle, which is basically saying that we have on one side this pole with safety security, we have the other side the cost, and then we have all these emerging topics with connectivity, with electrification, with sharing and services, and autonomous driving. And we need to optimize along this triangle because obviously the available competence and budget typically is not sufficient, and for that reason the implementation and governance of safety and security, in order not to fall down, needs to be efficiently addressed, and that's a major topic of this presentation about the experiences, how to efficiently implement safety and security. The two topics increasingly belong together, safety, security. And what we can see here, this is just a kind of a reference architecture of car. And we will see that security, cybersecurity, is the major challenge in automotive, but also that we realize that it's heavy liability risk because typical security flaws are detected rather late and often by a third party, which both is not so helpful in order to address the risk upfront. These are some examples which we recently see, and from a, let's say, experience perspective, the good news is that some type of previous security attacks, such as changing the mileage of a car or simple man-in-the-middle attacks to steal a car, these are going down very fast. On the other side, we will see an increase in terms of ransomware, and we will also see an increase in different attacks on the bus systems in cars, typically for the reason to make some changes in terms of functionality, but that of course has then also an impact on functional safety. So let us look into how these different topics relate to each other. First and most important is the functional safety. We've been addressing functional safety over the past 20 years quite decently in electronic system in cars. And we have a set of suitable methods such as hazard analysis, FMEA, etc. Cybersecurity came a little bit later in automotive. It's currently fast growing as an awareness and a precondition for functional safety. We do have also a set of useful methods, and the nice part is that somehow they can be even merged with the functional safety methods. Then there's a third one which we typically separate between cybersecurity and privacy. The difference being that with cybersecurity we first of all treat what are internal threats such as IP protection, IPR protection, such as protecting the vital functions of a car versus attacks from outside. Here is more the threats to privacy data such as the contact information which you have in infotainment, or the different places where you have been with the car, and other such personal driver-related information. We see also clearly a kind of a hierarchy between these three, which means that functional safety has the highest liability risk. Cybersecurity is seen as the risk for functional safety, so we have to protect from a safety perspective. And privacy we typically handle in terms of cryptography and encrypting the critical information. And I will show you some of the aspects here to implement it with some kind of comprehensive systems engineering, because that is the way how we see in Vector the recent experiences. To give a short overview on the situation with standards, we have from a historic perspective a very strong focus on the ISO 26262. The standard recently is evolving into its edition 2. It's rather bulky standard in the meantime. The edition 1 was some 500 pages, edition 2 will be 700 pages, but it also addresses a lot of domains, such as semiconductors will be in the new edition. There will be some handles to connect safety and security, but we should not expect too much in terms of supporting the full set of cybersecurity. For that reason, we also have a set of security standards where we have on the one side the classic ISO 27 series, which is about security management, key management, governance standards, etc. in the enterprise. We have some implementation-oriented standards, such as common criteria, and we have more recently the evolution of dedicated automotive cybersecurity standards, namely the SAE 3061, which was a kind of a fast workaround that connects nicely to the 26262, so that these two standards build together a starting point for cybersecurity. More to the future, the work has started on the 21434 cybersecurity standards in the automotive domain, which we are going to see over the next 2 years. What it means is that we connect some of the best practices in cybersecurity, such as threat analysis, such as some architecture protection, with mechanisms which we already know from the functional safety environment, like MISRA rules, which we have just heard in the previous presentation, which apply equally also to protect the coding and design base for a security matter. So it is from a perspective of this triangle, which I've shown before, important to have the safety and efficiency closely connected, and therefore our recommendation today is to focus on building initial cybersecurity structure around the existing functional safety structure. What it means is practically all companies today have good functional safety environment, which means safety managers, a lot of methods, tools for safety case and for consistency checking of the safety case. And these elements can be extend it with a baseline of cybersecurity so that we cannot exploit a given safety requirement by applying some attacks to a system. To give an example, if you have in your safety standard a connection of two ECUs on a CAN bus, then maybe there's a certain risk assessment which shows the CAN bus can be infiltrated either by denial of service, by replay, or by other mechanisms. Then the threat analysis based on cybersecurity mechanisms would give some recommendation. If this is an ASIL CD related connection of ECU, like in an active steering or braking system, then you better encrypt the communication path along this CAN bus, maybe also harden it to some degree with some protection schemes in order to ensure that the safety case itself would not be impacted if there is a security-related attack. To summarize the state of the practice in these two domains is that we have in functional safety a worldwide rather good understanding of the 26.26.2. We also have some line of handover between OEM Tier 1 and of course from a constructive perspective, this is also where the vector portfolio with our AUTOSAR and with the different vector tools nicely fits in. We will still have some presentations today in the afternoon on, for instance, the Prevision PLM environment, which can manage the whole set of safety case, but also our AUTOSAR environment. So for today, if you have a mature process environment with ASPICE 1 together with the 26.26.2 environment, this is a solid foundation, which should also be future safe towards the evolution in edition 2 of the 26.26.2. The picture in cybersecurity is a little different because this is now just evolving. I mentioned that there's two major standards, the currently available 3061 standard, which is an initial baseline to enrich the 26.26.2, and in addition to that, the 21434, which is emerging currently, and when it will be released would be then the industry standard for automotive cybersecurity. What we can already recommend now is that, first of all, the existing safety mechanism like hazard analysis should be extended towards threat analysis, so to at least protect the critical ASIL critical components and functions. Reuse the safety artifacts like your test environment, what we have just heard in the previous presentation, to make your safety case more robust, to harden it against a cybersecurity attack, and then of course also apply methodology like defensive programming and using certain coding rules like MISRA or CERT in order to protect the coding base. One step more would be to encrypt the bus communication, such as with AUTOSAR 4.3 onwards, where you have a good set of crypto library. Our vector AUTOSAR solution provides also specific components which not only allow end-to-end encryption, but also some onboard intrusion detection and prevention system for the ECU, and also hardware-defined security with Trust Anchor, which we built with different semiconductor suppliers. So this approach will certainly help in order to improve the situation with respect to cybersecurity in the current situation. From a perspective of software development, the clear recommendation is to oversee it with a risk-oriented perspective, like we know already from functional safety. That is, move from some high risk, which is unacceptable, to an acceptable risk by using a set of methods where we recommend using an approach which we have in security built over the years worldwide. Start with the protectable assets, look to potential attacks, find the threats and evaluate these threats, and I will show in a moment how this can be done efficiently. But this together will allow to have an intelligent and efficient approach to mitigate security risk. From perspective of the assets, which is the starting point in security, the major one at the moment, given that we have restricted competence and budget available, is clearly the functional safety. Then we have a few other asset categories, specifically around finance risk, which is liability, brand image, because we don't want to have some accidents in the newspaper and the media. Operational performance, that is driver experience. For instance, if we think about how to interact with the driver, we have to find new ways to communicate if there is a threat, because it would certainly not make much sense if a driver gets on his infotainment screen a warning that a virus has been detected. So we need specific cloud services which can filter this information and translate into useful behaviors for the driver, which is what we call a kind of a graceful degradation, not only a fail operational, but also certain scheme of failure handling, so that a driver can still drive, but maybe not anymore autonomously. He has to guide himself. Maybe some functions will be, based on the redundancy concepts from functional safety, be less available at the moment, but we should certainly be very careful that the user interface will not bring the driver in a situation that he doesn't really understand what should he do. Is the car still protected? Is the car still able to drive? This is a major challenge in this interface between finding security flaws and giving the right amount of communication and information to the driver. From a tool perspective of what we are doing in Vector, I want to just give a snapshot on three tools which fit towards what I was just explaining. One is our security check, which helps to assess the situation in respect to threat analysis, based on architecture analysis, on software analysis, and also processes. Then something which relates to the continuity of a kind of incremental delivery scheme is to maintain the safety case in a more continuous basis, even in very heterogeneous environment, to shorten the time between available solution and doing all the regression schemes in order to release software, like from a perspective of SOP. That's in a way similar to what we just heard about Jenkins, but more suitable for environments in the automotive domain. And finally, of course, the Prevision PLM environment, which has very mighty and powerful mechanisms in order to go from the requirements to the safety-related requirements down to the implementation and managing the respective test and documentation which is necessary for the safety case. To give you a short case study, which we have been doing in a customer project that's from a powertrain situation, is that there is a very simple scenario with two ECUs that have to do with adjusting speed and also some automatic gear shifting. And obviously, this is a rather high ASIL level. And then we have, let's say, safety-related hazard, which is on the speed adjustment. And then we can, in this safety analysis, extend it with the threat analysis. That is what I earlier meant when I explained that the threat analysis comes as a kind of enhancement to the risk analysis, which we do in safety anyway. And therefore, first and most important protection scheme is to harden our ASIL BCD kind of environment with respect to cybersecurity. And once we have this robust hardening, then we can move on to the next protection schemes which are necessary from a security perspective. We need, of course, to document for two major reasons. One is that we have to enrich the safety case, And once we enrich the safety case in terms of additional test cases or additional protection schemes, which would add on to the safety requirements from a security perspective, this needs to be documented. Second, from a liability perspective, it is relevant that in the case of an attack, we can prove that we as an OEM or Tier 1 have followed the state of the practice, and for that reason, some documentation is necessary. As I pointed out earlier, using provision for the safety case is already a very good mechanism to build upon. From a design perspective, we strongly recommend to separate the subnets so that where you have highly safety critical systems, there should not be any kind of, let's say, easy connection to infiltrate. The showcases which we have seen in journals and media releases over the past 2-3 years were all related to a centralized topology, which is today not anymore recommended, specifically knowing that for the next years to come, a car which today hits the market still normally has not a full over-the-air upgrade mechanism, which would actually be a prerequisite for ensuring cybersecurity. And for that matter, since this car would still be some 5 to 7 years on the road and needs to be sufficiently protected, we do not want that we have to call it back to the garage every other year or even every other month because of some security flaws, as we see, for instance, in our smartphones or laptops. So the only way is really to make very hard protection schemes around all the safety-related functions, and where we have the interfaces to the outside to make sure that we have the right firewall structure, and that means very specific firewall policies, VLAN, but also IDS, IPS, and of course some protection to the outside, for instance, when it comes to diagnostic interfaces, that we protect as much as possible, because that, of course, would allow to infiltrate from the outside directly in an ECU, and so here we need a very dedicated hardening. Going through the whole life cycle, there's not much time now to explain all the recommendations. Starting in the design, one of the first things we recommend is the before mentioned MISRA rules, because MISRA supports both the situation around functional safety and in many cases also is already a good way forward for robust design from a security perspective. Use static analysis tools like what we have seen in the vector software presentation. There are different such tools available. Lint is better than nothing, and from a perspective of static analysis, it's important then to adjust the filter criteria so that you don't get a huge amount of messages, but a few messages like what we have just seen in Steve's presentation with this heat map. That is a nice visual layout in order to focus on 2 or 3 areas where complexity is high, and at the same time maybe some MISRA rules are not observed. That would be then a starting point to improve the different ECU software. In perspective of test, the topics which we recommend is to, as much as possible, run a test suite like our canoe fuzzying testing, but also some possibilities for encryption, hacking, etc., vulnerability scanning. And finally, always use pen testing, penetration testing, in order to have that external perspective. What would a hacker do? The challenge is that for security, different than for any other of the classic test schemes, we cannot simply go with coverage criteria. We cannot simply go with functional-oriented testing. We have to test for the unknown, or as we say, thinking like a criminal and behaving like an engineer, which sometimes is certainly not what we are educated, being engineers, but what we need to do in order to balance the different test cases and have a useful automatic regression scheme. Lastly, it is important that we consider the after-sales, because the V alone is only initially protective with a lot of upgrade after sales. And as I say, today the standard is still not that we have full OTA coverage, and that means we have to prepare for good software upgrades that can be checked and can be by means of different mechanisms like hash, like checksums, etc., be ensured that you have the right data and the right software which goes into the software. Second, for the after-sales services, think in terms of the whole chain from resilient programming, which happens here, to operational strategies that, for instance, include alert centers, repair, and of course more and more OTA, and not the least also some governance schemes, because especially in bigger companies we cannot be sure that the enemy is not inside the company. And so we definitely recommend also some schemes like pair design or pair reviews, where you would have some additional supervision, or MCDC coverage with your unit test in order to find unused code which you should immediately eliminate. The over-the-air is the mechanism which is most relevant from a security perspective. So specifically in the domain of open interfaces like infotainment, like head unit, like diagnosis, OBD ports. There we should start with our OTA and FOTA strategy in order to allow fast upgrades. To conclude, we do have a new scheme, because we have to consider not only development, we have to consider service, we have to consider production with the different provisioning of data for configurations, etc., and operations, both for incident management but also for upgrades. From a perspective of efficient implementation of standards, we recommend to bundle the mechanisms as much as possible, at least initially, safety and security. A lot of the steps can be enhanced from a safety perspective into a security perspective, which makes the implementation easier. Of course, then we have to see also the cost benefit of the various mechanisms, because to protect everything is impossible. There is no 100% security, but we certainly can see, based on our own situation, what would be the best possible cost-benefit trade-off. For instance, we currently work with some customers, OEMs, which move into Ethernet, and of course then the Ethernet, which typically would be used in the infotainment head unit environment, is of course quite easy to attack, because there are numerous tools around for hackers, but at the same time also there are many mechanisms which we can deploy in order to harden such systems. The vector portfolio is very comprehensive. You probably have seen also the booths already outside. We have heard about our vector software, vector cast test environment. We will hear about the Prevision design environment. We have heard this morning already about the environments from a diagnosis perspective. Later we still will also hear some aspects about Canoe. And as I mentioned, all of this environment contribute to securities like the recent evolution for fuzzing. Then we have hardware-based security for our AutoSAR stack, which allows trust anchors. And we have the different security and safety consulting topics, which go from initial checkpoints to the whole set of security manager and safety manager, which we handle virtually. That means also able over distance in order to coach the people. There's more information on all that in our white papers. We have recently contributed to the prestigious IEEE software on a special issue on automotive software, which Vector has guest edited. And there is a lot of topics which go beyond what I explained today, but it's worth having a look to that to get benchmarks and to get also some experience, like from projects which we are doing with OEMs on future reference architectures. And that brings me to an end, and thank you very much. Arigato.